Light enters through the cornea, anterior humor, lens, and vitreous humor. Then the light projects onto the photoreceptors of the retina, and the retina sends impulses to the optic nerve, which is then carried to the brain. When it is carried to the brain, it is converted into image. This whole process happens without us even thinking about it. It all happens in the blink of an eye. And when we receive the signals of what we are looking at, it's actually an upside-down image. But our brains are smart enough to correct it. Now let's think about how our eyes help us at crime scenes. Eyes help in crime scenes tremendously. They identify crime scenes, suspects, evidence, and much, much more. They explain the surroundings. For example, in the picture below you can see a blood spread. If we didn't have eyes, we couldn't see this. As obvious as it is, there's a lot of blood there. If we didn't have eyes, we couldn't see it. Evidence solves crimes. Without being able to see evidence, we could not solve crimes. Take a moment and think about how life would be without eyes. Now think of how you would solve crime if you didn't have eyes, if you couldn't see the crime in the first place. You possibly couldn't do anything but infer. You could not find a suspect by description. You probably wouldn't even know a crime had taken place. If we did not have eyes, we could not do fingerprinting or compare substances because we could never even know they were there, much less that such things existed. Therefore, we could not solve crimes if we did not have eyes. Eyes are basically the basics to solving crimes, because if you can't see a crime, is it even a crime?
Forensic scientists don't have a specific camera they choose, they get one that best suits their needs. The megapixel in cameras is worth the light determines the quality of the picture. If the number is high, that means good because the quality of the picture will be good. The flash is an extra light needed to shoot inside or low conditions. Most digital cameras had a built-in flash with the range of 15 to 16 Cameras with feet. Manual focusing is useful for close-ups as it lets you focus on exactly what you want to. Photography is used to provide an accurate account that cannot be altered. The crime scene is for photographs to minimize the risk of conflicting statement. It's also used as a means of display of nature of a crime scene to officers of an investigative team who was not able to attend. Also, some crime scenes you're not allowed to use the flash because the flash can glitch and take it differently than what the actual picture was. In forensics, you have to take pictures from different angles, not just from one. Closer ones are the most important ones.
Today we are going to learn about lasers and how they function. Lasers are an acronym for light amplification by stimulated emission of radiation, laser for short. Laser beam is a special type of light. First, let's talk about how light is produced. Each electron has different energy levels. Once an electron is heated by an energy source, it gets excited and jumps to a higher level, but it doesn't stay up there forever. Once it drops back down, it sheds the extra energy in a packet of light called a photon. The timing in which this happens is random. Some electrons may drop back down after 1 microsecond, and others might take 10. Another way an atom can emit light is when an atom is already excited by electricity and is hit by a photon of specific energy. This can make the atom simultaneously emit a daughter photon with exactly the same energy and direction. This is called stimulated emission, and it means if you have a material full of excited atoms, you can start with 1 photon and very quickly amplify the signal to produce millions more, all of them identical to the first. Stimulated emission happens in a cavity filled with atoms and with mirrors on both ends. An electrical spark excites the atoms. After the atoms have absorbed the energy, they have to release it in the form of a photon. When the photon hits another atom, it releases an identical photon. The mirrors bounce the photons back and forth, stimulating more atoms to drop an identical photon, therefore resulting in amplification. As the photons multiply, they begin to look for the opening in the mirror that only reflects 99% of the energy, and the 1% is an opening in which the energy is released as a extremely bright and straight beam. The beam of a laser is parallel while a torch beam spreads. In fact, the beam is so straight that a briefcase-sized mirror left behind on the lunar surface by the Apollo astronauts in the 1970s is still used on a daily basis to reflect a beam back to Earth in order to accurately measure the distance to the moon to a precision of less than 1 millimeter. Also, a laser beam can be focused onto a tiny point, meaning they can make delicate incisions during surgical procedure, like laser eye surgery. When laser is focused, it can heat a spot to thousands of degrees. This makes the laser a powerful cutting tool. Lasers are also used to amplify signals sent along fiber optic cable, which is how most of the information on the internet is transmitted.
Advantages of eyes, cameras, and lasers in crime scenes. Our eyes have to be super absorbent in crime scenes. With our eyes, we have to find the objects used in the crime scene, like the weapons. We have to record the simplest stuff, such as the weather, time, and pick up the small things that you would think would not care. Cameras are great for recording information. They help us take pictures of blood, any weapons found, and how the furniture could be moved around the room. Pictures could help us absorb a crime scene better because we could see things that we would never have. So cameras in a crime scene can help by taking pictures or also recording the evidence. As a forensic scientist, one of the best kinds of evidence you can find is fingerprints. And lasers really come in handy when the powder that forensic scientists use, made up of carbon and aluminum, fails them. When that happens, lasers come in. Unlike regular light, lasers are composed of only one color light.